everybody. This is Mark Long with Carlson Software, and welcome to today's webinar for Precision 3D Topo 2018. Today, I do want to give folks a little bit of a chance to get on who may be late coming to it. So probably the first thing I want to show you guys is that we've kind of updated the Carlson website in order for you guys to find out a little bit more of the information and the product, some of the specs and things for the product. And if you go to the Carlson homepage, just so you know, you can come down here into their product families, and Precision 3D is here, which will take you to this portion, this web screen. Okay, and we have different things that we could do in here, such as our importing, talking about the importing of data, editing, things that we can do, editing our clouds, things like that, editing surface, volumes, things like that if you're interested, sharing, texturing, presentation tools, things like that. Our feature list, which tells us everything just about that the program is capable of doing. Companion products for the software, and also if you intend to purchase. Also note that down here on the bottom, I know that I had a question just a second ago about system requirements. So this is what we have going on for system requirements. The laptop that I'm running on today is an i7. It has 32 gig of RAM, a solid state hard drive, and a video card, an NVIDIA 1060 video card in it. So just so you guys know, it's nothing high end. It's about your average run-of-the-mill laptop. So getting that, showing you guys some of that stuff and letting you know that you can go and find out even more information here. Also remember that we have YouTube channels that you can go and watch all kinds of movies about Precision 3D. If you are looking to just fill in the gap of something that maybe we haven't talked about, or you'll find just about everything that you need in those movies, and we keep updating them and adding them. We want to make this product about as simple as it can be for you guys. So let me go ahead. With that being said, I got about 10 folks here, it looks like. So I'm going to go ahead and kind of get started. Today's presentation is probably going to be about 30 minutes. It's nothing crazy. So just sit back and enjoy. If you have questions, you can certainly type them into the GoToMeeting panel. And I have Nathan Cruz with us today. He's the lead programmer and the pretty much the main man for Carlson Precision 3D. And I'm again Mark Long, and I'm the product manager for Precision 3D. So if you do have questions, you can certainly add that and ask them, and we'll answer those for you as quickly as we can. So let's go ahead and get started here. First of all, before I do, can everyone hear me and see my screen? If you can, in the GoToMeeting dialog box, there is a raise your hand. And if you can hear me and all that stuff, could you please go down there and just raise your hand to let me know? Thank you very much, Robert. Thank you. Thank you, guys. Awesome. All right, let me go ahead and hide this little GoToMeeting thing off to the side here, and I'm going to close my web browser. And we're going to start with our presentation today of loading in LIDAR tiles and data, also loading in drone flight data, merging the two together, and showing you some of the features that are available to you in the software. So we'll get started by launching our P3D. And the very first thing I'm probably going to do here is I'm going to go and load a P3D file, because this will set my projection for what I want to show you guys. And we'll talk a little bit more about that in a second. So I'm going to go into my Kentucky LIDAR here. And I'm basically now going to load in tiles that were sent to us via the transportation cabinet of Kentucky. And so I want to go in here. I'm going to load my point cloud. Now let's talk a little bit about what we have here. The options that we have here is that first off, if you go and choose your point clouds, I could come in here, go to Kentucky LIDAR, and we can load up to 50 different tiles at one time. So by selecting the top one, scroll your mouse wheel, grab the bottom one, we can load up to 50 at once. Now, that doesn't mean you're restricted to just 50 tiles. It just means loading them at one time. So if you needed to, you could load 50 and then load another 50 and then another and so on. But at one time, which is really convenient for a lot of folks. So let me go ahead and open these. And you will see that they populate down here of the point cloud file names. So each one that I loaded has its own little spot down here. And you can see when we get down here to the bottom, there's close to 30 of them. Okay. It tells us in this the file name that we selected, the number of original points. This is the original number of points in point cloud, and each one looks like it's about 7 million. I'm not going to do any thinning factor, and it shows us the number of points to load. And also if it found classified data, and these say true, so it knows that we have ground classified data in these tiles. So when we come up here to select our thinning factor, I'm going to set that to 0, and then I'm going to say load only ground classified points. Okay, so once I select that, now you can see that the point count stays the same of the original points, but what we're going to load drastically is reduced. And so this is when you have those LIDAR tiles that have that classified or bare earth type of scenarios in them. If you look up here, I'm going to use the projection in the file, which it doesn't really have any, but I'm going to go make sure that I set these to Kentucky. Let me slide this over, single zone US survey feet. Okay. And that's how the data was downloaded from the website. So let me go ahead and load ththese point clouds.
Hey, Mark, before you do that, you don't want to apply a projection in this case because we don't need to. Because the website for Kentucky says that they're all done in NAD 83 Kentucky single zone US survey feet. So in this case, we actually don't need to do the transform, which is going to make it faster.
Okay, thank you. Let's go ahead and load the selected point clouds. That was Nathan Cruz, by the way. And I will load this in US survey feet. And now we're going to load the 30 tiles, and you can see that there is something's going on here, and you get the blue spinning wheel, and it'll take it a second.
You told your task monitor there, where we're loading each individual tile in a separate CPU thread.
Yeah. So behind the scenes, when this thing is working, we're loading in 30 tiles at one time, and this is multi-threaded type of processing. So if you have 8 cores on your machine, and you're like an i7 or like mine does, this program is taking advantage of all of your resources you have available. If you have 16 gig of RAM, 32 gig of RAM, whatever the case may be, the program will use that the optimum amount that it can. But if you don't have the 32 and you're 16, it will throttle back, so that it doesn't interrupt, if you have other processes going on down here or other system things going, that it doesn't, cause those problems. So it's very multi-threaded, really. So that's kind of what Nathan was talking about, taking advantage of all of the system that you have available to you.
And including RAM. So if you have 8 cores and 32 gigs, you can load more and larger tiles simultaneously because you have more RAM. So we do watch the current RAM usage as well. And if there's not enough available RAM based on an algorithm that we have for loading files, then basically we'll just push that back in the queue, and we'll wait until there's enough RAM to go ahead and start that thread up and request that much more memory. So we basically will not crash your machine loading lots of LIDAR tiles all at the same time.
Okay, so basically what you can see is happening right here now is it's about all 30 tiles are being loaded into this scene that we have. And when it gets done here, I'm going to point out, I'm going to merge all these tiles together and that type of stuff, so we have one point cloud when it gets done.
And even though we only loaded the bare ground points, since we did 30 tiles, which I think this area turns out to be something like 17,000 acres, we're still loading and dealing with about 175 million points in total. And you'll see that we're loading around 77 million actually into the scene itself.
This is taking a little longer than it normally does. I wonder if it's kind of throttling back because of GoToMeeting and the webinar. So we're still just going to let this thing keep doing its thing. Or is it done? We'll just have to see. I'm just going to let it sit here for a second because it's usually done by this time. It doesn't take this long to load these 30 tiles, to be quite honest with you. But when it's all said and done, if you look, just the tile that I selected alone is 573 acres. So loading 30, we're going to be quite, the acreage is going to be quite high. Not 100% sure what I'm getting here or why it's doing what it's doing.
Well, and to be fair, this is a pre-release of our next update. So we just did this build last night, and it looks like, oh, there it goes.
It's almost doing it. It's almost like I have to delete all of these boxes, like the boxes didn't go away or something to that effect. It's hard to tell at this. I mean, it's done its thing. And it looks as though if I selected, I'm just going to keep trying this so you guys can, so we could just keep kind of going. You see, I've selected all 30 tiles.
Can you just move the box out of the way?
Yeah. We'll just put it up here and kind of leave it up there out of the way. And now, once, you know, basically once the point clouds are loaded in here, I'm not sure what causes this ordeal right here. I honestly don't know. I've run through this example before I come to show you guys this, and it worked fine. It could be something with the webinar. I do not know, but it's a little unusual. So what we can do once these tiles get loaded in, we can select one tile, or I can hold down the control key and slide a box and select all the tiles, or I could come here, select one tile and hold my shift key down just like we do with Windows, you know. And at this point, everything is kind of context sensitive. So if I have point clouds over here and I highlight one point cloud, the things that I can do with this point cloud are represented here. If I right click, you can also see the exact same commands that are up here are here. Okay, so now in this case, I want to kind of come up here. I'm going to get all these point clouds and I'm going to merge them all into one. So if I right click, because I prefer right clicking, I can merge the point cloud. So these are 30 LIDAR tiles that we're going to merge into one. And so we'll let this thing do its little spill, and it usually doesn't take long, but we'll see. So again, just like we had talked about earlier, you know, there we go. See, things are working. I just got this dialog box. It's like a remnant of something over here. So probably webinar.
Yep. So how many points do we end up loading in our overall?
It's not
Here, that'll
it's
come up.
not quite done. There we go. Now we're merged. So if I highlight our point cloud, we got 17,000 acres that we just loaded in here. Okay. We also loaded a number of points of, it looks like 77 million points here. So in this case, the transportation cabinet was looking to try and work on a roadway corridor. So they don't necessarily need all 17,000 acres. So what we could do here is they exported out a DXF of a polyline from their CAD of the area of interest that they want to study. And so we can also import those CAD polylines. In this case, they made me a DXF. And so I'm going to load in and import this DXF that they had sent me of their focus area. Okay, so I'm going to open this file here and load in this polyline is what it is. Now it's here, but I need to turn the point cloud off to see it. You guys see the polyline? That's the polyline from the CAD file. I cannot drape a polyline to a point cloud. I can to a surface model. Okay, but anyway, so that's where that polyline is. So what we got now is we've got some tools that we could come in here and let's start to kind of whittle this thing down from 17,000 acres, 77 million points, and get it down to a smaller, more manageable size. So if I come up here, we have commands here in these point clouds that are here, but I like to right click because you see the names. So I could crop and delete by polyline here. I can isolate points here. I could crop points if I want to, but I'm going to crop and delete polyline by polyline because that's what I just have. And so now if I hold down the control key and I window across, I select the polyline underneath, I have options here, or I could have just drawn the polyline if I want to. But now I can either crop points, I could delete points, or I could create a new cloud from the enclosed points. Let's do that one. Let's see what happens. So I'm just going to tell it I want a brand new cloud out of the points within the polyline of the scope of work. So we'll let the program go ahead and give us that here. So it's basically looking at the let's say limits of disturbance or something to that effect to get it to isolate those points in that cloud. And so now you can see, boom, I got a whole nother point cloud. I've got two now. One is of our scope of work, which we'll go up here and just change the color of it just because I want you guys to be able to see it stand out a little bit better. So we'll change it to color and elevation. And here you're able to see that we've created, we still have our main point cloud that we started with, but we created a whole new one of the scope of work that of the area that we're going to deal with. So in this kind of, now we could have just deleted those points, the gray points out here if we wanted to. Sometimes people don't want to delete their points, you know, they want to keep them. But basically what we did was we just took and made our own new cloud. Well, we can come down here now and save this point cloud. Okay, so if I save point cloud, we have options in here where you can name it whatever you want to. Okay, you get just a naming convention, but we also have a LAS format. 1.4 has projection burned into the header of the LAS file, so the program knows where you're at. Other programs don't have that capability, so we have kind of, at least yet, and so we've kind of been able to save it back to older versions to be compatible with other softwares. Okay. So if you wanted to save it back as a 1.2, you just give it a new name and you hit save the point cloud. So that's how you can deal with 30 LIDAR tiles at a time and merge them together. You can isolate your scope of area that you want to work with, create a new point cloud, crop the points, and now you're ready to make a surface model out of all these points and start your design work. Okay. I'm not going to save the point cloud back. So I just wanted to make sure you guys saw that and whatnot. Now, what I am going to do is I've got another example of some stuff that I want to show you guys. So what I'm going to do is I'm just going to close this, and let's see what happens if we restart and rework the brain here just a little bit. I still got that box still stays up there. I'm telling you, it's the webinar series or something, Nathan, that's causing that. Let me go ahead and restart the product again, okay? And we will go, this time I'm going to load a scene file, open a scene file, and this one is in a different location that's in Maysville, Kentucky. Okay, this is the headquarters of where Carlson Software is. I'm going to come down here, and in this case, I'm going to load a drone flight that we had done and LIDAR, and I'm going to piece them together. Okay, and so that we have a hybrid type of surface. And so anyway, I'm going to go ahead and load the point cloud. I need to choose the point cloud first here. Let me get into the right spot. Let me grab this Maysville LAS file.
And here we're going to want to use the projection. So this is where Precision 3D and our companion product, Carlson Photo Capture, work really nicely together, because in this case, now we're in Kentucky North US survey feed, so we're in a different zone than the previous example. And we're going to be loading in an aerial drone point cloud that was captured using a UTM zone 17 in metric units. So in this case, we're automatically detecting that, and then we're going to apply that proper projection for you automatically. So you don't really have to think about it other than setting your current working scenario to your typical job location.
Right. So the data was given to us in this UTM 17. We want it to go to Kentucky North US survey feed. That's what's about to happen. Right. So if now in this case, maybe I do want to apply a thinning factor. I got 3 million points here. I'm just going to reduce it by 3. Okay, so basically, if I thin something by 3, that means the points that are being loaded would be like 1, 3, 6, 9. You know, that's the point number is that's what's being loaded.
And then we don't have classified data typically for aerial drone photogrammetry.
Yep. Right. So if you find classified data, you could load only ground, but this one we don't. Most drone data won't. And so anyway, now we can go ahead and load our selected point clouds. In this case is really just 1, and we're going to end up with about 1.1 million points. So I'll load the selected point cloud. It's a big difference in loading 30 tiles versus 1 drone flight that you have here. And so this is Maysville, Kentucky. It's the Ohio River here. We got a river boat, looks like pulled up to on the Ohio River there. You see a pool for a hotel downtown Maysville, Kentucky. But what can we do? Let's start thinking. Well, one thing that we really need to do is kind of get down to the bare earth of this point cloud and see what we can do to manipulate this point cloud to make it to where we could design things with it. Because if you zoom in here and you look, you see you've got rooftops, you've got the boat over here. That's not surface stuff. So we need to kind of start weeding through some of this data and making it to where it's usable. Okay. So if I select the point cloud, again, I have my options of the things that I can do. If I select the filter point cloud, looks like the hammer and the saw here, I could come in here and I could apply a bare ground algorithm to this point cloud. Okay, basically it's doing a 10 by 10 window sample size, and anything that's its neighbor, basically anything that every point checks its neighbor, if it's 3 feet or taller, then it gets removed in a nutshell. So I'm going to go ahead and apply this bare ground filter. I'm going to set this to 2 though, and we'll do 10 and 2 and apply the bare ground filter. Now what you should see here is when this gets done is a lot of the vehicles, small brush, things like that are gone from the point cloud. Okay.
This is also a highly multi-threaded operation, by the way. So what we do is we actually break up every individual tile and run it in a separate CPU core to do the analysis. So you can see how quickly it took out all the cars and the majority of the brush.
Now, it's still left rooftop. Okay, you see that data there. There's still some rooftops here. This is actually the top of Carlson Software's headquarters right here. And so now we've got tools and oops, I just got a little wild on my mouse wheel there. Let me get back to plan view right quick. Zoom down in here. And we'll rotate this thing around a little bit so that I
You can probably turn off the pixel optimizer too, so it's a little denser.
All right, so there we can get back to this about what I'm looking at. Now what I'm looking at here is to go ahead and start removing stuff manually. Okay, in that case, I can run a command here that is isolate points, and then I'll show you how this behaves. So we come in here, we run the command, we come out here into our scene, and we start drawing kind of a rubber band. Okay, you see how I'm kind of rubber banding to include points in this cloud. Then I select keep enclosed in selection. Now you can see those are the points right there that I selected in my cloud. Do I want to keep them? Do I want to delete them? Or do I want to create another new cloud out of it? And in this case, I don't need those, so I'm going to delete them. So there's, again, another way of manually manipulating your information. So let me show you another thing that you can do here. Let's just say you're looking at it from this perspective, okay? And you decide to come in here and you're like, well, I got to get rid of this rooftop, okay? And so you kind of come around here doing something like this, okay? Like so. And you say keep enclosed in selection. Well, when you come back and you look, it's like, uh-oh, maybe I got a little too much. Okay, well, you can continue by just coming back in here and drawing your red polyline around the other points that maybe you accidentally didn't mean to include. You see? So I'm gonna come around through here like so, maybe get these points and say, I'm not ready, I just want that roof. You know, so you can remove enclosed from the selection. Okay, so the points stay back, and then we could just say, now I'm happy, let's delete these. Okay, so now you're basically kind of manually cleaning up your point cloud. You're going to have to do a little bit of this type of stuff in order to get things down to the way you want them. Now let's think about this even more. Well, I got my riverboat sitting out here. That's not Earth. So let me go ahead and grab a hold of this guy. We'll take him, we'll just kind of eyeball right here around the toe, what I call the toe anyway, but the bottom of the boat, boom, keep enclosed in selection, boom, and we don't want to delete them. That's kind of cool. Let's just leave it. Let's create a new cloud. Now, the boat is there, but it's not part of my main cloud. It's its own cloud. So if I wanted to, I could right click here and rename it, just call it boat. Okay, so now I could turn that off if I want to, and it's gone, but I didn't delete it. See? So now that we've got this information, we need to load in the LIDAR. Let's get the LIDAR from Kentucky. Okay, so I'm going to come up here. I'm going to load point clouds. In this case, I'm going to go choose point cloud files, and here are the LAS files associated with Maysville, Kentucky. Okay, and I'm going to open these. You can see, we got true date. We got true. So the found classified data. Here's the projection that file is in, and we're going to take it to Kentucky Siegel Zone North. Okay, I'm not necessarily going to remove any of these points, but I do want to load the classified points only, so the ground points only in this file. Okay. So if I select now, load the selected point cloud, it will come in here and load the whatever 9 to 10 tiles that we have of this LIDAR.
And again, in this case, it automatically detected that there was a different projection burned into these files, and it's automatically putting it in the right location in the scene.
So now, in this case, we've got 12 different point clouds in here. Well, I could take all my LIDAR tiles and I can just right click and merge those into one. Okay, so that's what we'll do. We'll let this thing merge into one. So there's our 1 point cloud there. And again, if you wanted to change the name and change it to US 64 LIDAR or something to that effect, Maysville LIDAR, you could change the name by just renaming it here if you like. And then what we're going to do is, now what we end up with here are two different types of data that we've collected. One is a drone flight. Okay, I'm gonna turn off my riverboat because I don't want to include him. One is my riverboat. One of them is the LIDAR, and the other one is our Maysville drone flight. Okay, so let's go ahead and see how we could piece these two pieces together. The first thing probably that I would do in a case like this to merge these two together would be probably turn on my planar snap, which is an elevation snap, and I can draw a polyline around the perimeter of what I want to basically kind of delete. Let's just say that's kind of what this is doing. We're just going to delete the LIDAR underneath our drone flight so that we can make one hybrid surface out of it. You can get as tight in there as you want to. I'm just kind of just showing you guys. Close the polyline like you would normally. Okay, now with this point cloud selected, this is the LIDAR point cloud. Now I could come in here and crop and delete by a polyline that I've selected on the screen. By highlighting that point cloud that I want to do, I can come here and just remove points out of that cloud. So I'm going to come here, select crop and delete by polyline, hold down my control key, right click, select that mouse, select my polyline, and then just say we could crop, delete, create a new cloud. In this case, I'm going to delete the points inside of my polyline. And so now I'm left with the drone and the LIDAR. Okay, again, at this point, we could just go ahead and merge this one, this guy. I think it did it. This guy and this guy. Oops, excuse me. Hold my control key, grab that, and merge these two together. Okay, so if I merge these two together, we'll have just one point cloud now. So there's, you have those types of things of merging a drone flight into a LIDAR tiles, or whatever you want to call those. And then our polyline, since we've kind of used it, we don't need it anymore. You right click, you can delete it, get rid of it. And now you're ready to make you a surface model from this.
And if you put the display type back to from file on that, you should still see the colors from the merged part of the cloud.
Yeah. So yeah, so the color method is from the file. So you see.
So now where LIDAR doesn't have color, but the just showing that the point cloud, we do maintain all the data even when we're merging and saving the point clouds as far as the colors are concerned.
Right. So now we can also come in here and crop our point cloud even further, because we don't need all this out here. We're not working out here. We're just worried about area in here. Maybe we're updating our river walk or something, and we just need this amount of stuff. So I'm going to crop this point cloud, and I'm just going to basically pick here and come across my scene here a little bit. I don't think I want to do that one. Hold on a minute. Let me get plan viewish so I can see. I want to turn off that planar snap too. Let me come in here and look a little bit more down. I was getting looked like a little bit lopsided there. Crop my point cloud. There we go. So let's just crop it to that area. And now we're left with, here's the area that we're left with. This is what we need to do for our design. Now, we could go ahead and make a surface model out of this and do all that kind of stuff, but you guys know I didn't clean up all the buildings and all that kind of stuff. But the last thing I do want to show you guys is the ability, another really cool feature in the program is bringing in Google Earth images and things like that. So the program automatically knows where we are we're geo-referenced here. So when we click on the import Google Maps downloads, we don't necessarily need to worry about finding a location because it knows where we are. And basically here as well, we can do a zoom level. We can do tile the size. We don't have the surface model yet, so I can't drape my image to the 10. I can't drape it to a point cloud, but I can still bring that image in if I want to. And also down here, if you want to create a new surface model that's from Google Earth, you can download that in here as well. Now, I'd probably set for something like that, I'd probably set it to like 25 by 25 or something to that effect. So if you do that, then you can also get the surface, another totally different surface model 10 from Google. You know, I'm not going to do it. I'm going to bring the image in for you guys and let that be. So basically, when we bring in the image, what it does, it goes out, grabs the image from the Google and fills it in with our buffer size to the outside. And so here you can see, there's the LIDAR. Here's the Ohio River bridge going across Maysville, Kentucky over into Ohio. Okay, I can turn this off if I wanted to. There's the image. I can also come in here and you see how the LIDAR and the Google Earth image are there. It needs to be. I could raise the image up. So let's just say I raise this image up to 1,000 in elevation. Now the image is above the point cloud. Had I made a surface model, it would have been draped to the 10. So
you could go ahead and load that again, because that should be pretty quick in this case. Just maybe reduce your buffer size.
yeah, I'll do it. So let's go ahead and I'm going to reduce that buffer size to what, maybe 50.
50.
And then we'll create the surface model and we'll go 25 by 25.
Turn off find location now. Otherwise it's going to go to Apex. There we go.
And so now we'll just do it again. We'll let this thing load and get the surface and it'll be draped. But
so in this case, whenever we create a surface from Google, in this command, we automatically drape the image to the Google surface that we create. And then that way you'll be able to see just how closely it matches the LIDAR data. So the Google Maps surface data turns out to be a lot more accurate than we had anticipated. So now Mark can zoom in there and you can see just how close that LIDAR data matches the actual data.
Yeah, you could see, you know, the data from the LIDAR and the Google Earth. The Google Earth is if I turn the LIDAR off, the image, let me turn off the image overlay right quick and turn back on my, I need to see my 10 and my textures here. But there you can see there's the textures of the Google Earth surface here. Okay, we turn the overlay back on. There you can see the overlay. I'm going to turn off the textures here. You can see the overlay, and then you can also turn on the LIDAR. There's the LIDAR. You can turn back on your riverboat if you want to. There's our riverboat down here, over here somewhere. So again, that's how you can bring in LIDAR, the different tiles of LIDAR, merge point clouds, merge drone flights, manipulate your clouds a little bit. I showed that. And you know,
we can also do one more thing, and that is we can do field to finish for the Carlson survey users out there, or actually any survey package that can export survey data in land XML format, or a Carlson CRD. But you can also import those points and break lines directly, or you can use our field to finish processor, which will basically connect all the points and put in 3D symbols for trees and power poles and things like that. So you can actually augment this data even further by bringing in your survey data.
Do we have, looks like we got some questions here. Nathan, have you gotten those? A lot of hands up.
I was just looking. I don't see any more typed questions.
It may be, that may be where I ask people to put their hands up just so they know that I'm here.
Okay.
if there are no more questions, if you guys have questions, you can feel free to just type them in, and we'll wait here for just a second. But that's really today's presentation, and
And you
we
can
hope you
also
enjoyed it.
email us at p3d@carlsonsw.com if
Mhm.
you have any further questions about the software. And again, you can find the website. We're on the carlsonsw.com website under the P3D product family, and it lists all the features, and you can request a free 30-day demo. And then you can also get a link to the training videos that show you, I think there's about 22 or 24 training videos of different flavors, kind of broken down a la carte.
Yep. So, is there any questions you see, Nathan?
No.
All right. Well, thank you guys for attending. I appreciate your time, and look forward to hearing from you. So, have a wonderful day. And
Oh,
if we
wait
don't
a
see y'all
minute.
again, happy
I'll be
holidays.
scanning one more, Mark. Be scanning the inside of our treatment plant as well. Could the software? The answer is that you could bring in the it doesn't matter if the points were captured with laser ground scanners or with photogrammic equipment or traditional airborne LIDAR. You could still bring those scans in, and then you could still use our point editing and cleanup merging tools to basically clean up all the stuff that you want to have inside. The thing that we don't do with plant models is we don't create surfaces from plant models, obviously, because we have round pipes and so forth. And the Delaunay triangulation doesn't match that very well, but you can bring in the different clouds and you can do the editing of them. And then you can resave them out to disk for further processing.
I hope that gets everybody's questions. Thank you for coming, and I hope you have a wonderful day.